Okay, so section 3.6, we're going to be solving radical equations. Sounds like fun to me. Anyhow, for the most part, I'm just going to be solving a bunch of problems and talk you through each step along the way. So, part one. So, you're going to see lots of these radicals in physics and electronics and so on and so forth. And we've seen several already in some of the applications we've done. One thing we should be aware of when we're solving equations with radicals is sometimes we could introduce an error when we square both sides or we cube both sides or things like that. So one of the things we're going to want to do is to check our solution into the original equation and see if it works. And that's something that will come up in probably part 2 of this lesson. So this is going to be an important step. So I'm going to work these out and pretty much, whoops, let's back up. So basically you could use the common sense here. We basically, like any algebraic equation, we undo everything. So to undo a cube root, we're going to cube both sides. So that should not surprise you. Cube this side and we cube this side. Well, the cube cancels off the cube root. That's why we did this, because they're inverse operations. So this cube here cancels off the cube root. So we have 2x plus 7. On this side, if we cube 3, we get 3 times 3 times 3, which is 27. And so we just solve this simply by doing some basic algebra here. And we get x is equal to 10. Now, it's not a bad idea to start out by checking to see if this works. And I'm going to recommend that you just get into the habit of putting the number back into the original expression and see if it works. So if we erase this and see what we originally had, well, let's see what happens. 2 times 10 would have been 20, plus 7 would have given us 27 here. And the cube root of 27 is 3, so it does work. So there you have it. Let's do a couple more and then we'll be done with this lesson. Part 1, and then part 2 we'll just do some more of these. So solve the equation, check your solution. Okay. This is a little bit blurry, but there's a cube root here. There's an x here, and then a minus 9. Now keep in mind that the minus 9 here is not under the cube root. So probably what we should do is just move the 9 to the other side of the equal sign. So I'm going to do that by adding 9. 9 over here. And I get the cube root is equal to 8. And now the inverse operation of a cube root is to cube both sides. And so I'm going to cube both sides of my equation. Put a cube here, cube here. And of course this cube will cancel out. And so we get x is equal to, this is just simply 8 times 8 times 8 again. And let me just use my calculator for that. I think it's like 512, if I remember correctly. 512. Yeah, I'm going to get my calculator here and check. Yeah, it's 512. Okay, so again, it's not a bad idea to check this out and put it back in the original expression right here. If we were to take the cube root of 512 cube root of 512 is equal to 8. That would be 8, and then minus 9. That does equal -1. So it does work. And so that's what's meant by checking your solution. And it's just a good idea to always check your solution when you're doing these radical equations. Here's another one. So some people will ask, well, I have to do the inverse operation of this cube root here. It's a little fuzzy again here. And so anyhow, I think it would be smarter to get rid of this 2 at first. And so I think what I'll do is divide this side by 2 and divide this side by 2. And then that'll give me the cube root of x minus 3 is equal to 2. And now if I do the cube root on both sides, I get these cancel off. So I get x minus 3 is equal to 8, because that's 2 times 2 times 2. And of course the final step is just to move the 3 across. And we get x is equal to 11. Well, once again, it's not a bad idea to check this in the original expression. And this usually isn't going to be a problem with the cube root because you can take cube roots of negative numbers. But it might start to become a problem if we're doing a square root or something like that. Anyhow, let's just check and see if it works. If you do 11 minus 3 here, if this is 11, then you can get 8. Okay, so that whole expression here in the middle, this part right here in the middle would be 8. Okay, well the cube root of 8 is 2, so then you'd have 2 times 2, which does equal 4. So that is what we have over here. So everything seems to be working just fine. Well, this time, let's see what happens. Well, to undo a square root, we want to square both sides. So I'm going to square this side. That will undo. Now remember, the index on a square root is actually a 2. It's just we don't write that in there because that's the default. But I need to square this side also. So when I square this, this cancels out the square root. So I get x plus 25 is equal to 16. Because 4 times 4 is 16. Well, now I subtract 25. That's 25. Subtract 25 here. And I get x is equal to what? Negative 9? Well, so let's check and see if this works. If I put the negative 9 in here, I would have a negative 9 here. Well, negative 9 plus 25 is equal to 16, and so the square root of 16 is equal to 4. So sure enough, this one even works. So anyhow, there will be times where the answers do work, and sometimes the answers won't work. Like I said, I think they come up in part 2 of this lesson. Well, let's try an application problem, just so you can see how these problems might work in real life. It says wind velocity in a hurricane, the mean sustained wind velocity in meters per second is given by this equation. So velocity of your wind, 6.3 times 1013 minus p, where p is the air pressure. And that's what's kind of interesting. The air pressure in the middle of the hurricane is not that much. You can fly a helicopter inside the middle of a hurricane. It's kind of interesting. Anyhow, we can estimate the air pressure at the center of the hurricane when the mean sustained wind velocity is 54.5 meters per second. So a lot of people, when they're doing stuff, they don't know where to put these numbers in. Does it go in here or does it go in here? Okay. Well, the key to answering these questions is to find the letter in the word problem, you see? And then they'll tell you what it is. Like, there's your V. The V stands for wind velocity, and they tell you also what units it is. This is a meter per second. So this one, the V of P here, is measured in meters per second, whereas the P is air pressure, and it's measured in millibars. So the fact that they're telling me meters per second tells me that the velocity that I'm putting in for is this one over here. So a lot of amateurs, uh, they guess, and sometimes they get lucky, and sometimes they don't. Anyhow, this is going to be 54.5 is equal to 6.3 times the square root of 1013 minus p. Well, as we've seen on other problems, it's probably a good idea to get rid of the 6.3 before we square both sides. Because we want to square both sides to get rid of that square root. So I'm going to divide by 6.3 here. Divide this side by 6.3. Using my trusty calculator, I get 4.5 divided by 6.3. I get basically 8.65. And that's equal to the square root thing. Okay, so then the next step is to square both sides. So I'm going to square this side and square this side. And of course the square cancels out the square root. And so I have 1013 minus p. Now let's see here. I get 74.82. And so then what? Let's see. I need to subtract the 10, move this over that way. So subtract 10, 13, subtract 10, 13. And I get negative p is equal to negative 938.18. And of course, if I multiply through by a negative, by like a negative 1, it changes this one to a positive, and changes that one to a positive. So I get p is equal to 938.18. Well, of course, this answer would be in what unit? I think it would be in millibars. Yeah, see up here, the air pressure is measured in millibars. So that would be millibars like this, MB. Now it seems like a lot of air pressure, doesn't it? Let's just take a moment to look up what the standard air pressure is for, with no wind, like outside, standard atmospheric pressure. And I think it's pretty close to this. So what it means is that there's not much more pressure than we normally have on a regular calm day. So we could do that. I'm going to exit out of here for a moment. And let's just, for our curiosity, check this out. Okay, so I'll just type in standard air pressure for ATM in millibars. Okay, so Okay, so a pressure of 1 atmosphere can be stated as 1.01325 bars. And that's equal to these pascals, a kilopascal. And then they say, oh, it's equal to 1013. You see, so that's where they got that 1013 because that's the standard atmospheric pressure. And so actually, the pressure inside of a hurricane is a little bit less than that. It's like 900. We came up with 900 and something. So there you have it. And now you understand where this number came from. That was part of our equation. And so, interesting stuff. Okay, so we'll go back to the PowerPoint now. And I think we're pretty much done. Um, we don't, well, let me just do one more of these as test prep problem. How do you get rid of the exponents in this case? We have 4x to the 2/3 power is equal to 36. Well, again, if there's any numbers out in front, I think what I'd like to do is get rid of them. So I'm going to simply, I think I'll use green now. I'm going to divide by 4, and now I get x to the 2/3 power is equal to what? 9? And so what I want to do now is I want to get rid of this 2/3 exponent. Well, the way you do that is to multiply by an exponent here, or raise this to an exponent. Remember, when you raise an exponent to another exponent, you end up multiplying the exponents. So what we want to do is take 2/3 and multiply it by some fraction here that's going to cancel out the 2/3. Well, the usual trick is to use the reciprocal. So I'm going to multiply by the reciprocal. So notice if I put 3/2 here, then these are going to cancel, and the 2's are going to cancel. So the trick is to use 3/2 here, and raise this also to the same exponent, 3/2. Okay, so this 3/2 and this 2/3 will cancel, and so what we have left here is x. Okay, so now to evaluate this, remember the idea, if you could rewrite this somehow as something squared, it can cancel out that denominator. So that's my plan. I'm going to write this as 3 squared. And now what will happen when I raise it to a new exponent is I'm going to multiply these exponents, and this exponent will cancel off with the denominator there, and so now I have 3 cubed. And that's simply equal to 3 times 3 times 3, and so x is equal to 27. And remember also, when we have a square sitting right here, like if we had x squared equal to 16, when we take the square root here and the square root here, we end up getting plus or minus. We get x is equal to plus or minus 4. And that's why we have the plus or minus up here for answer D. We have a plus or minus. And the way you could see that, I could show you a little bit more slow motion here. For example, if we had the x to the 2/3 power, what we could do, let's add this to the 9. What we could do is raise this to the 3rd power and raise this side to the 3rd power. Okay, and then these 3's would cancel, and so then we'd have x squared here is equal to 9 times 9 times 9, 9, 3, and whoops, we would have a 729 here. And then what we do is take the square root on both sides. Well, because we have a square here, we'd want to have plus or minus. And so, sure enough, we'd have the square root. And we'd get this is equal to 27. And we'd have plus or minus again. Okay, well, there you have it. We worked out several problems, and this will take care of part one.